Right, with this you need to read the question carefully to get your head around what's going on. A metal bar has a uniform cross-section in the shape of a trapezium ABCD. So what you're seeing there is the front face of a three-dimensional shape. So what that actually looks like is, if I was to draw it three-dimensionally, you'd have that there, and then coming back off it, you'd have that like a sort of gold ingot or whatever. Now, in order to work with density, there's a formula that you need to know, and you're not given it, and the formula is density is mass divided by volume. Okay, so density is mass divided by volume. Now, if you can't remember that, in any density question they give you a huge clue, because they always give you the units they want the answer in. So you can see there, they want the density given your answer in G/cm3, where G is grams, which is mass, the slash is over, and cm3 are the units of volume. So they're actually telling you there what the formula is. Density is mass, grams, over volume. So if you can't remember it, you can get it from the information they give you in the question. Now, volume of a prism you are given on the exam paper. This is the formula list that you've got at the front of your exam paper, and what we're looking at is this piece of information here. Okay, volume of a prism is the area of the cross section times the length. So what we have is a cross section which is a trapezium. So if we can work out the area of that, and then we multiply it by the length to get the volume. Now, we're also given the formula for the area of a trapezium, okay, and it's this: it's half times a plus b, the sum of the parallel sides, that side and that side, times the distance between them, h. Okay, so let's look at what we know about our trapezium. Oh, sorry, they're telling us what the area is, so we don't need to use that formula. They're already saying that the area of this is 48.7 centimeters squared. So in order to work out the volume, I know the area of the cross section, I just have to multiply it by the length. So the volume will be 48.7 multiplied by the length, and it's telling me there it's 12.8 centimeters long. So it's already in the right units, which are centimeters. So there's the volume. So if I just bring the calculator on the shot, 48.7 multiplied by 12.8, 622.36. And its volume, so the units of that are centimeters cubed. And now, in order to work out the density, density is mass divided by volume, but I need the mass in grams, and the question's giving me the mass in kilograms. So first of all, I've got to change the mass into grams. I know, you need to know, that there are 1,000 grams in 1 kilogram. So to change that into grams, I'd multiply it by 1,000, 3,200 grams. So density is mass divided by volume. So it's 3,200 divided by 623.36. Turn it into a decimal and round that off to one decimal place. 5.1, the next one is less than 5, so it stays at 5.1 grams per centimeter cubed. And that job is done. Okay, and then the second question we're going to look at here, This one's drawn three-dimensionally already. Diagram shows a cuboid. We know its length. We know that PR is 24.7, QR is 16.3. So the first thing they want us to do is work out what PQ is. Now I'm hoping that you'll spot there that what we actually have is a right angle triangle there, where we know two sides and we're trying to find the missing third. So what we have to do there is Pythag. Okay, it isn't trig because we don't know any of the angles. So with Pythagoras, it's one of the shorter sides that we're trying to find. So in order to do that, it's a subtraction between the square of the longest side and the square of the other side. So PQ squared is that squared less that squared. So let's work out what that is. .7 squared take 16.3 squared, so that's 344.4. But I don't want to know what the square of PQ is. I want to undo that to get PQ. Opposite squaring is square rooting. Okay, so on my calculator now, I need to find the square root of that. So if I press the square root button first of all, and rather than have to type in 344.4, if I press the ans button, it puts in there the last thing that I worked out. So 18.558, rounding that off to one decimal place. 5 is one decimal place. You look at the next one, 5 or more rounds up, so 18.6 will be one decimal place. Okay, and then for the second part, density of the material is 4.3 grams per centimeter cubed, and I want to find the mass. So density is mass divided by volume. So I know the density is 4.3. I don't know the mass. I do know that, I don't know the area yet. The first thing I need to do is work out what the area, what the volume of that is. So scratch that for a sec. So the volume of that is going to be the area of the cross section, which is going to be 18.6 times 16.3, and then I have to multiply that by the length of the shape, which is 53.1. So the volume is 18.6 multiplied by 16.3 multiplied by 53.1. So 16098.858 off the screen. Right, so density is mass divided by volume. I want to get the mass on its own, so I'm going to undo divide by V. The opposite of dividing by V is multiplying by V. So the mass is density times volume. You may have been taught to remember the density equation in that form. Okay, density mass over volume. If that's the case, then you remember, right, if I want to find the mass, I'd cover up M, D and V are on the same level, so they multiplied. So mass is density times volume, which now is going to be 4.3 times that big number there. So we multiply that by 4.3 and we get 69225. Don't worry about the rest, grams. We want the answer in kilograms, so we'd have to divide that now by 1,000 to turn it into kilograms. So divide that by 1,000, 69.2 kilograms. Okay, and 69, one decimal place is 2, the next digit over is less than 5, so it stays as a 2. Okay, so when you're dealing with density questions, you can see there that you've got to work with volumes and areas as well.